Okay, in this problem we have this. Consider the journey of an aircraft or boat or so on running. It doesn't make a difference. Somebody is moving from A to B and then flying away to C from B. So you're going from A, B, C. Okay. Pose B on a bearing of 45 from A. So B is from A on a 45 degrees bearing, while C is on a bearing of 140 from B. Okay, so let's draw that part so that we can see what we are working with. Okay, so let me put the problem there. I'll take it piece by piece. So we say that the journey from the aircraft from point A to B, so you draw your diagram. I'll just put NERD there, A to B here, and then flying away to C to B. Point B is on a bearing of 45 from A. So B is on a bearing of 45 from A. This is 45 bearing. This is B. This is A. Okay. So this is 45. This is B. This is A, because B is on a bearing of 45 from A, while C is on a bearing of 140 from B. So C is somewhere around here, but that is on a bearing of 140 degrees. So you're going to measure from this way and get 140 for C. Okay, now that's 140 bearing, that's point C. Now that's up to that point. These points are such that point C is east of A. Now recall the cardinal points, right? If you are east, then you are directly across. So therefore, these two are level. Okay? So that is the diagram that we will be working with. It says, sketch a diagram of the problem showing clearly the information given, which we have done. It tells you now, determine or calculate the angles A, B, C, B, A, C, or A, C, B. Those angles there, they want you to calculate the length EAC, the bearing of A from B, the bearing of B from C, and the bearing of C from A, and the bearing of A from C. So let's start with the angles then. So we're going to start with this piece here to start to solve everything here. So if I want any one of these angles here, notice what happens here. This angle here is 90 degrees because C is directly east of A. So if this is 45, this must be 45 degrees also. Notice what I said, 45 degrees. I did not say that bearing, I said 45 degrees. So we come here now. If this is 45, notice what we have here. This angle and this angle are equal because they are alternating angles. So we put here 45 degrees also. This angle here makes 140. This is a straight line. So if we take 180, take away 140, this gives us 40 degrees. Notice what I'm doing. I'm just using with angles at this present. So if I have 45 here and I have 45 here and I have 90, then I could figure out what is this angle, because that's the total angle in a triangle. So you take your calculator and you say 180, take away this 45, take away the other 45, and take away the 40, and that gives us 50 degrees. So this is 50 degrees. So we have labeled the triangle with all its angles inside. So tells you calculate, determine the angle of ABC. So angle ABC is actually 45 plus 40, which is 95 degrees. Did not say bearing, say angles. Angle BAC, BAC, that is equals to 45 degrees. Angle ACB, so angle ACB is equals to 50 degrees. So we finish with that part of the problem now. So we go to the next one. Determine or calculate the length AC. What is this length here? Okay, so what can we use here? Did I tell you any distances that they were apart? Okay, let me see. The journey of an aircraft, 45 degrees, 140. Okay, they didn't give any distances. So we want to know what is the length AC, this length here. Well, they didn't give us any distances, so let's put some distances here. This one here, we will be making it to be, say, 20 kilometers. Okay, so if this is 20, or we could have given any other side, except that we are looking for AC now. We have opposite sides, so we can put now that AC over the sine of this angle, which is 95, is equals to the 20 over the sine 50. So AC is equals to, okay, so you solve that, you get 20 times sin 95 over the sin of 50. So we do our calculations. We take 20 times sin 95 equals divided by sin 50, and that gives us then 26. So EAC is equal to 26 kilometers. Round it off to two significant figures for right now. Okay, so we get here to be 26 kilometers. Now we have now EAC. We could figure out what is BC now. If we want, we can use sine rule again and get the length BC, but you're not being asked for that, so don't worry about it. So we go to the next part. It says, what is the bearing of A from B? This bearing of A from B, well, the bearing of A from B is actually this angle here. What is that angle comprised of? It is 180, which is a straight line, plus 45. So you can put here 45 degrees plus 180. That gives us 225 degrees bearing. So this is the bearing of A from B. Notice why. The 45 plus the straight line. So that is 4D. This was 4C. And B was this one here. Okay, what is now the bearing of B from C? What is this angle here, this bearing? They want to know of this. That's the bearing of B from C. B from C. Well, if this is 12, then what was that? This was what degrees? No, that wasn't 12, that was 40. So if this is 40, this must also be 40 degrees. Okay, so we put our 40 degrees here, and so we subtract 40 from 360, which are angles at a point. So we get that E is 360 minus 40, that gives us 320 degrees. This is bearing of B from C, which is this one here. All right, calculate the bearing of C from A. Well, C is east of A, so directly that is on the horizontal, so F is 090 degrees bearing. That's the bearing of C from A. Now calculate the bearing of A from C. They want to know, what is this? this angle here. But remember, if this is 90, right, then this must be 90. Subtract 90 from 360, and that gives us then 90 from 360. That will give us 270 degrees, which is the bearing of A from C. And so we finish with the problem. Okay.